All right. Well, with that being said, I think we will go ahead and get started. Bear with me one moment here. All right. In terms of setup, couple things to note. This requires a little bit of explanation. If you are wanting to participate on your local machine, the package that is involved is the 51 package available in the PyPy marketplace. So you can install 51 with just pip install 51. It does require having Python on your local system. I think, unfortunately, I'm blanking on the minimum Python version, but it'll tell you pretty quickly what it is. And then as we get started, you don't have to run these yet, but some of the fundamental kind of programmatic commands we'll start running are these import commands to start pulling in a basic demo data set that we'll be working with. In addition, we do have a workshop notebook that accompanies this. I'm also going to put the notebook put in chat if in case for whatever reason this QR code is uncooperative. Let me put it in here. Yeah, thanks, Burhan. Um, and then of course I will double check that it opens. Okay, it seems to. Yeah, so I deliberately hosted the notebook here in Colab so that there's a couple ways you can interact. If you have like a Google account, you should be able to interact or copy the notebook or run the cells directly within the notebook. I worked pretty hard to make the steps pretty embeddable, including the UI. If you feel more comfortable downloading it and running the commands on your local system, you can do that. You can run it as a Jupyter notebook. You can copy and paste the commands. The goal is to have it be a little is for it to be portable in that sense. There are a couple things towards the end of the notebook that are left as exercises to the reader. Just for the sake of time, there's a couple things like I think there's like when it comes to like running model inference that just due to the time it might take to run inference, I'll kind of cut to the chase and show you the results of what you would run. And then on the AI side, I have my like coding agent set up locally, and I'll demo that as well. But um, that's tougher to embed directly in a notebook also. But that being said, as we go through, the goal is to make this, as practical as possible. So that being said, for those that have joined, this workshop is ultimately for folks that are working with particularly unstructured data sets. So think modalities like images, audio, video. Um, and if you work with computer vision flows with those types of modalities, this is the place for you. If you have heard of 51 and are interested in how it works as an open source project, this is the place for you as well. If you've kind of finagled with it before and you just want to get the fundamentals down, this is the place for you as well. This is not particularly in depth on like computer vision or Python programming fundamentals. This is more application focused on particularly on the data set and curation and model val and annotation, all those computer vision flows using 51. Um, a phrase we tend to use here that we've had for a while that we've used internally is that we take a data-centric AI approach to what we do. Basically, kind of the fundamental theory that we base pretty much our company off of is the idea that curating better data sets, higher quality data sets, more representative data sets that are easier to search and access the metadata of. That's fundamentally what moves the model, what moves the needle these days on model performance versus just tweaking model architectures. So there is a place for models that are involved here, but really the goal is how can we curate the best data we can and understand it so that we can build better downstream models. As I mentioned before, this session is being recorded. We encourage you to use the Zoom question and answer for questions. There is not directly a certification that accompanies this workshop. If for whatever reason you need like proof that you attended, though, we can definitely help out with that. We have a registration of everyone who attended. If that's something you need, feel free to reply to the follow-up email after this, and we can probably get you taken care of. And again, we'll start a little bit conceptual, but then again, the goal is to pretty quickly get into the application side. All right. So here's what we're going to cover over the next 45 minutes. what is data-centric AI? That is why is data the bottleneck. What is 51? There's actually a few components involved. It's fundamentally a client server application that's served as a Python library, and we'll talk about that. What are the kind of the core capabilities and workflows that you would do as you onboard yourself onto the platform? What types of data sets and media does 51 support? Aside from just understanding and what we call curating your data, how do you perform tasks like annotation workflows, model evaluation, and so forth in the platform? And then lastly, we'll focus on the AI assisted side of things. And really where that's going to go is it's especially useful for those getting started with 51. 51 is an extremely composable and programmable um, application. And if you incorporate things like coding assistants, think Claude, Codex, Cursor in your day-to-day workflows already, there's some tooling that 51 offers that allow you to onboard yourself pretty quickly, even while you're still learning the ins and outs of the SDK. So, starting really quickly, what is data-centric AI? Data-centric AI is the proposition that models are getting commoditized. So there was, and that comes from a statement a couple years back by Satya Nadella, good old Microsoft CEO, where he proposed, again, there's some people that disagree that models themselves are largely converging, right? And that the optimization curve of improving models is starting to converge. They're getting commoditized both on the open source or open weight side and on the proprietary side. And that the differentiator these days is the actual data being used to train and fine tune these models. And again, going pretty quickly through this initial slideware here, like, again, we really can't re-emphasize enough the idea of garbage in, garbage out. It's not even the quality of the data itself, it's understanding what data you have. It is not uncommon that people will work with their data like this, right? Everything's in a spreadsheet. You're open up, the manual file explorer in the UI. You're making like notes here and there. The metadata is not super consolidated, right, into kind of a single interface. And that's not bad. It's just helpful if you have a place where you can actually see your data's modality alongside the metadata that you work with. And that's largely what this project is intended to provide. Um, because, like I said before, garbage in, garbage out. If you don't know what's training your model and you don't have an understanding of your data's quality, that can be a real problem, especially because visual data in particular requires accurate ground truth to as like axiomatically, right? Like the entire basis of being able to have real world models is having accurate ground truth and accurately labeled data in the first place. And incorrect or inconsistent labels can cause model performance to degrade in a way that doesn't show up in the evaluation metrics. Because if the evaluation is dependent on having an accurate ground truth in the first place. So that's where 51, this is what 51 is designed for. There's a couple ways you can think of what 51 is. I said before it's a Python library, and that is accurate. Some ways that you can think of it is it's sort of like an IDE for your visual computer vision flows, right? Just like in VS Code, the goal of it is to have an interface that is intuitively designed to work with source code. 51 is like that, but the idea is it's kind of a way that is purpose built to having a way to surface and understand your visual data alongside all the metadata metrics and workflows you would do alongside it. And ultimately, when we talk about 51, it involves a few key things. There's the core SDK. So there is the actual 51 Python library that you interact with. Skipping the middle for a second, there's the UI because it's ultimately visual data that we're working the most with. So the visual UI is, where you can actually like visually examine, and also run some operations against your data, perform things like annotation and so forth. And then lastly included is a library called 51 Brain that includes a variety of machine learning routines that you can apply against your data. Think like embeddings computation, computing from that similarity indexes, uniqueness, representation, routines to evaluate core model metrics like precision, recall, F1. And again, the goal here is to, again, provide additional insight into your data. And I'll bring up the app here in a second, but the goal is that you can have multimodal data in a single interface. So this is a kind of blurry, so I'll open something up here, but you can work across data types, not only between data sets, but within a single data set. So for example, if I open up this 51 environment that I have here, and I'll just open up the new scenes data set. This is a multimodal data set that is what 51 calls a grouped data set, right? So within a single scene, we have multiple camera views, LiDAR, in the form of 3D point clouds, and all of it's consolidated together, in this case, in terms of time series data. So you can have, plain, regular two-dimensional image data sets, but also 51 supports this grouped data set concept as well in both the individual sample level and in terms of how it's visualized in the sample grid. Like what part of each sample do you want to show? And due to the support of just visual data in general, that also allows 51 to support like uh, more domain specific data modalities like geospatial data, DICOM in the medical field, and then due to the ability to host spectrographs, audio data as well, and as well as video. 51 supports video data also. Okay, so how do we get started? And this is where we'll start kind of exploring the notebook a little bit. 51 again is at its core an open source project. We have an enterprise version as well that's designed for like larger deployments where you have more intensive clustered compute operations in particular, as well as the bells and whistles like SSO, role-based access control, kind of those more enterprisey features as well. But out of the box, 51 is fundamentally an open source library. And part of the initial way you can use it is immediately start onboarding and visualizing your data sets. So I'll jump to the notebook here in a second, but the easiest way to get started, there's a couple ways. If you have your own custom data, which is typical that you're importing, you can use the 51 SDK to start reading in that data. Again, at its core, out of the box, all 51 needs is a local directory on your file system that will contain your samples and the associated metadata files. And then you can start importing it. If you want to if you want to onboard even more quickly, you can start by importing what's called a zoo data set. So 51 has what's called a data set zoo and a model zoo that are public data sets and models that can be imported and used with a single method in the SDK. It's a way that you can very quickly onboard onto the platform and get started. So if I go into here, into the notebook, let me zoom in a little bit. If I just want to quickly get started, I can pip install 51 and then a few dependencies that are used later for things like embeddings computation. And I'll let that run for a minute. I'll pip install the package, and then just a couple cells down, I'll initially import the data set. Now, if you're following along in the notebook or you're running it in Colab, you'll see a little bit of noise here at the very end. There's a couple of like Colab related libraries that will like say there's a conflict. This'll still work. And I'll let this run for a minute. And then I'll open up the application inside this as well. So again, we'll just give this a minute here, and I'll flip back in a moment. But fundamentally, the core parts is 51, can run locally on a laptop, but it fundamentally acts as a client server application. So when we launch 51, we can launch it as a web service and then interact with the web service using the SDK. Right, we'll give it another second here. I think it's just finishing up. All right. While that's finishing up, again, there's the core 51 library that once 51 is installed, you'll just start in Python with import 51. Similarly, there's a library called Brain. So that'd be import 51.brain that gives you access to some of these tools we'll use like embeddings computation, embeddings visualization, and construct some useful metrics like finding similar samples, unique samples, samples that might have likely label mistakes using k-nearest neighbor type techniques. All right. So again, we see this error here at the bottom. It's actually okay. It worked. This is just a little bit of noise. And then if I quickly just check, again, a little bit of noise here. Promise it still works. I think there's just a slight quoting thing there. But we see 51 is loaded. And if I want to like immediately onboard myself, okay, right? All I've done so far is I've pip installed 51. There's just a little bit of Python code here. And I want to say, okay, how can I get started quickly? I just want to start by loading a data set. Well, what I could do is I can run this. So I've imported 51. I've also imported the sublibrary 51.zoo, I should have mentioned as well, and 51.brain. And then from there, I can create an object called dataset, and I'm just going to call this method called load_zoo dataset. Um, Probably the easiest way to get started is to load a dataset called quick start. That'll just pull it down, and it'll tell us that, hey, the data set's loaded here in a second. And it's stored locally within this environment. Again, this is fundamentally a directory that contains the individual samples as like JPEGs or PNGs. And then there's there's metadata stored in JSON uh, structures that contain everything from the sample metadata, the detections and where they are in the samples, um, file information, any labels on the samples, like I said before, of various types, and so forth. So for example, if we look at the first sample in the data set, we can see that there's actually quite a lot of information on it there, right? So here's the sample object. It has object detections. And if we look at, for example, the ground truth labels, we see these different detections and their coordinates. We can see that there's a bunch of birds, it appears. And we also see predictions that a model applied as well. Now, that's all fine and dandy, but this is visual data, and I can't make a whole lot of sense of this from a kind of high level perspective unless I view it in um, in an environment. So I'm going to launch the 51 app. This might cause a little bit of noise here at first as well. Just in this environment, it can take a second for the 51 app to load. Yep, so I just need to run it again, and then it should load here in a second. We'll give it a moment. Uh, the rest of the time I load it, it'll be a little less noisy. So there's a little bit of like overlap here. That's fine. But if we look at the 51 app, it fundamentally looks like this. Now, if you were running this on your own local system, again, the later screens will look a bit more square and correctly proportioned, I promise. If you're running this on your local system, you would serve the app at localhost 5151 by default. So localhost over port TCP port 5151. And here we can see some of this data. So the first sample was that sample here, and we can see that there's all these, and again, we don't exactly know how the different bounding boxes were applied here, but we can see that there's bounding box information that shows like bird, confidence score. We see ground truth. And then we see like, I guess there was this very noisy model that put all these other bird bounding boxes are with various degrees of confidence. And at minimum, just like purely starting off here, we're like, oh, okay, we see our sample. There's the ground truth. And there are maybe some predictions that were previously added. But you can also examine all the metadata here as well on the right. So at minimum, 51 gives you a sample grid where you can see everything laid out. You can see the metadata here on the left that provides some sorting and filtering capabilities, and you can open individual samples. So that's just like, square one. What can we do then? Well, there are some basic programmatic queries we can do on the data set that we can then render into the app to filter according to those queries. So we can construct what are called views that allow us to filter across the different metadata in our data set. So for example, if we look at our data set schema, we can see there's all these different fields, right? We have, it's all ultimately a set of ordered dictionaries. And now what I can do is I can start to query different aspects of this data set. For example, I could say, hey, what are the different object classes in my ground truth? And I can simply, print them out here, right? Ultimately, this is a dictionary, and I can just say, okay, there's This is, by the way, the quick start data set is a subset of the Cocoa data set, a public data set that has like a lot of like everyday objects in it. So there's everything from airplane and then, alphabetically down the line. But I might say, hey, I want to filter and only show samples that contain person detections in them. So I can create a view called person view and then filter based off samples that have the person label in them. And we can see that out of the 200 samples, 94 of them contain people, and I think this is by ground truth. Yeah, contain people in the ground truth. So the order of operations is we create this view, and then we call the session.view method, and then that will reload the app with that particular view up here. And note that there are some things you can do in the UI as well. So you can construct what are called stages that apply those similar filters directly in the UI. Here we just did it programmatically. Here's another example. Maybe I'll find simply images that have more than 5 ground truth detections. We'll call this a busy view. So we're going to run dataset.match where there's greater than 5 ground truth detections in those samples. And then we will render a view that contains all of those samples. Here there appears to be 73. So if we see this here again, we can see that there are 73 samples in this data set that contain more than 5. Again, are we still doing ground truth? Yeah, more than 5 ground truth detections per sample. We can also sort by some criteria. So maybe we'll sort by, if we ran a prediction model, sort by the number of total detections the prediction model made and order the samples by most first. And then we'll create a view out of that. So this is going to show those, this is going to show the samples with the most predictions first based off this model that we had. And again, you could filter further maybe by like object or class, right? Predictions in a certain class. And then lastly, you can tag samples for later reference. So there's this concept called tags here in 51, where you can it's not adding an annotation label, it's just adding a metadata label that says, okay, all samples where the model's confidence was less than 0.3, we'll tag them as low confidence samples. And this is a pretty, this model, had extremely high recall. So we can see that there's a lot of the samples where the model is pretty low confidence in terms of what we allowed to be applied as a label. So those are some of the fundamental curation techniques. Again, 51 allows you to be extremely composable and programmatic in this way, where you can create arbitrary views of your data. So when it comes to curation, you can do it programmatically, like we showed here, but there's also quite a lot that the UI exposes as well. So you might go in and you might say, okay, for predictions, I might want to filter based and only show samples that have a prediction confidence score of at least 0.85 or above. And we can see it looks like, actually, let me go back here. Should this work? I don't know why. It's resetting for some reason. Oh, it's because I had this view saved, so the view is resetting. That's why. This might work now. Hold on one second. So maybe the minimum confidence score is 0.85. Might be a construct of the UI here that it keeps resetting, but generally you can just set that minimum score and have it apply. I think because I created the view, it's trying to render the view here in this tab or in this iframe, so it keeps resetting. So I'll go ahead and move on. All right. So quite simply, we'll call what's called curate data, right? You can start to load in data, decide what pieces of data are important by various metrics, and then filter your data as well. But let me back up to that, what data is important. That's where those 51 brain techniques come in. There are a variety of operations you can perform that allow us to decide what is important about my data. So you might do things like compute the embedding space and visualize those embeddings as a cluster and compute things like similarity, uniqueness, and others. That allows us to use those 51 brain techniques I mentioned a moment ago. So that's where the 51 brain library kicks in. There's a built-in method called compute visualization uh, that uses, I think, UMAP by default but you can pass in any model or algorithm you choose that will compute the embedding space, and then we can visualize those embeddings in the app. Now, in this data set, the embeddings are going to be sample level embeddings at first, right? So you're showing the complete image embedding, and that can be useful for like unlabeled data, right? So if you're visualizing just what is the embedding space of my data in general that I haven't labeled yet, you might compute it on the entire image and kind of look at the distribution. Are there any outliers? Things like that. So I'll let this run for a minute and then go back to it. All right. Okay, we'll get to model evaluation in a little bit. That'll be next. But part of the platform as well is once we start adding models, we can run methods that allow us to perform um, both model inference, model training, and then we can evaluate our model's performance against the ground truth and have it all kind of visualized and filterable in the app. We can look at confusion matrices and things like that. So more on that here in a minute. Right. All right, now it's generating the visualization. So it computed computed image embeddings. This should finish here in just a moment. Right. So it's like watching a pot boil, right? As soon as you think it takes a little bit too long, it finishes. So we'll give it one more second here. If it's another 10 seconds and it isn't done yet, I'll move on for a minute. This will succeed though. All right, we'll let it go a little bit longer here. I think it's just finishing up. Probably should have added a little bit more GPU juice on this. Okay, should be. There we go. Okay, so now with embeddings computed, if I now open up the app, what I can now access is this embeddings panel. Yeah, and now I have a key that I associated with the embedding space. Now, on its own, we're just looking at the distribution. Um, this is showing like the whole image samples, right? And if it was like classification, this might be like somewhat useful insofar as like you can then filter the embeddings by image type. So I think this is taking a second here. And you can also put it side by side with the samples, and you could be like, okay, is there a set of outliers? Maybe it's here. For this type of data, though, this is bounding box detections. So whole sample level data, I don't know why this is wanting to reset on me. Hopefully that'll be fixed in the next iframe. But you can lasso different sections like so. There we go. And quickly we saw it show here. So I'll leave this alone for a minute. I think the CPU is just getting a little bit jumpy on me. But where I really want to show in a moment is a couple things. Number one is if you generate additional algorithmic metadata, such as like a uniqueness score for the samples, you can then color the embedding space by that attribute and see where things are clustered together. So for example, if I compute the uniqueness of each sample using a 51 brain method, that'll provide an additional thing that I can view in the embedding space. All right, this is still wanting to reload on me, but what have I done here? We can see that I have, yeah, created this view that sorts by uniqueness and shows the most unique samples first, according to this algorithm, right? So unique view equals dataset sort by uniqueness. And then if I open up the embeddings panel again, I can select my embeddings. And then I have this uniqueness attribute, which again, it's kind of wanting to reset on me. I can color by uniqueness, and I can see where my more or less unique samples are clustered together. Again, the reset's a little bit annoying, but I think you see the gist here. Thankfully, I'll move away from this embedded place in just a little bit. Where am I going with this? Well, one additional layer which is really useful is if you're working with object detections, it's less useful to make embeddings off the entire image. It's more useful to make embeddings at the object level. 51 calls these patch embeddings. So what I can do is we can create what's called a patch view that creates one sample per object detection. And the sample itself is that object's visual space, like the space bound by that object bounding box. So that requires using what's called creating what's called a patch view and then running the embeddings computation on that patch view. So if I now run compute visualization against the data set, I'll set the patches field as, say, the ground truth. And now I can evaluate where my ground truth labels are. So I'll let this run for a minute, but this will create a new view and a new embedding space that is now at the patch view level, and we'll see what that looks like in the app. While that's running, another word on data sets and media types. The core object we're working with in 51 is this data set object that we saw, right? So this is a container of sample objects with all of its metadata and all of its custom fields. I didn't mention this, but it is 51 is backed by a MongoDB database under the hood for the structured data. So think like the metadata and the sample level attributes. The sample data itself are regular files on your computer. So again, you can programmatically add or adjust any types of fields that you want. And those are things you could add to like your model evaluation metrics, for example, and custom dashboards and things like that. 51 will also infer what type of data that is being used from the file path generally. So for example, image, video, or point cloud data, it'll infer by the file path metadata file extension and will serve them accordingly within the app. So just another look, I think this is still running. Okay, 64 patch. There's a lot of object detection, so patches take a little bit longer. Just as another example of how it looks in the app, I showed you an example of groups level data, how it shows everything together. That you can also have individual 3D point cloud data. There's video data. Again, images like this. This is kind of blurry, sorry, but this is medical DICOM data. Geospatial data, if that's the space you're in. 51's kind of cool where it allows you to create side by side a coordinate map of that data alongside the samples themselves. So for example, this is a map of, I believe, New York City that's alongside the samples here, if I'm looking at this right. Yeah. Okay. Part of what we're doing here is proactively trying to find and fix data quality issues. And that can be done in a couple of ways. It can be done qualitatively by like visually examining the embedding space, but it could also be done quantitatively by computing metrics like brightness, blurriness. There's a tool called mistakenness that 51 offers that predicts whether ground label truth is correct or incorrect based on k nearest neighbor and other statistical techniques. Basically, is there a broad discrepancy between other correct ground truth labels and one that is supposedly of the same class? And what I think is most helpful is we'll see it here in the app in a minute. When you select one of those attributes, the sample grid will generally auto adjust based on what you selected. So we'll see it here when we lasso the embedding space. We'll also see it when we look at things like model eval metrics here in a few minutes. So it looks like this finished here. And now if I look at the patches view in the app, we can see it here. Now notice how the samples look different. In fact, if I get out of the embeddings view for a second, we can see that there are now, over 1,200 patches, and the samples themselves are like with respect to those particular object detections, even if they're sourced from the same image, right? So for example, if I click into this kitten here, we can see it's only showing the one object detection for the cat and nothing else from the source image. What that means in terms of embeddings is now we can look at the embeddings. Notice the space looks a little bit different now with respect to the patches. So now I can color by, if I can do this, detection.label. And now we can see, again, sorry, I'll go to a different thing in a minute. Sorry, this keeps kind of resetting on me. Now we can see the different parts of the embedding space. And we might say, hey, why is there like an outlier over here? Well, what are these? Well, I guess in this orange, these are, or this tan, these are probably elephants. And this will probably be pretty quick here. Yeah, we can see that was very quick. Sorry. Unfortunately, this isn't persisting for some reason. We can see the elephants quickly being shown here. And I think this is a collab issue that's causing it to not persist. Let me try one more time. I'll move to the demo environment here in a second. Yeah, so we have the embeddings functionality supports bring your own model. You can also use a model zoo model. Again, that's just 51 will kind of pull a common public model. Think clip, for example. You can also always bring your own. We generally don't do I don't believe we have any proprietary models. This isn't, again, the product is open. This is the fundamental open source product. So you can bring your own model or you can use a public zoo model. We don't have a baked in proprietary model for embeddings natively. All right. Okay. There's one piece I haven't discussed yet, which is annotation, right? So we were kind of looking at a lot of existing labels and seeing how we can visualize them, organize them, see confidence scores, compute the embedding space, compute patch embeddings based off object detections. However, on top of that, what about the labels themselves? Like, how do we create, edit, modify? How do we perform CRUD operations on labels? So as of the past few months, 51 now supports in-app annotation. 51 has always and will always has and will continue to support integration with third-party tools like CVAT. So there are 51 kind of native methods that allow you to like export labels and or annotation jobs and send them to a third-party source like CVAT, even proprietary software like Label Studio and things like that. But as of the past few months, there is in-app annotation. So what I'm going to do is there is something in the notebook that just like creates a new view to label. But what I'm going to do is I'm actually going to jump over to this demo environment just so it's a little bit more stable. And I'm actually going to back out of here and I'm going to see if I have my quick start data set up. Yes, I do. So I have just another hosted version here of the quick start data set. And we can see I have actually a lot more labels here. And I'll start with the ground truth. So let's say like, or I could start with no labels, right? It doesn't really matter. But let's say like I know I want to change a label. Maybe the ground truth is wrong. If I open up a sample, like maybe there's this here, this plate of food, we'll see that there is this tab over here on the right called annotate. And 51 takes a label schema approach to this. So if I click schema, we can see that I have an active ground truth field. What I could also choose to do is I could choose to set up another field, maybe this detections field, and import its schema as well. Maybe this is like a model applied prediction. So I might choose to scan for those labels and save them as a schema that I can modify as well. Either way, if I go back to the Explore tab here, if I want to edit any of the labels, as long as the schema is imported to FiftyOne's annotation framework, I can go in maybe here, and if something is wrong, for example, like let's say, this forks bounding box is, I thought I imported the schema. Hold on. Oh, sorry, this is the wrong thing here. Let me click on the fork. Well, let me. I'll go to ground truth. All right. Let me click on the broccoli here. And then if I go into the annotation tab, I can click on the label to edit. And then here it's easy as me as just dragging the bounding box to make the change, right? So like maybe like the broccoli is actually this big. It's not. This is going to be wrong, but you get the idea. And then it'll natively save in the app. With FiftyOne Enterprise, you do have dataset versioning. You can also use tools like DCS to like integrate with FiftyOne as well. So you kind of have versions of your datasets and therefore your annotations associated with them. If I'm adding new labels, so let's say I have an unlabeled data set, like no labels at all, I can also construct my own schemas. I can do so in the app here by creating a new field, maybe called my labels. And I could say that, hey, the label type is detections. Maybe it's classifications, right? And I might say, hey, this might be food. We'll do this animal, vegetable, mineral, right? So we'll do the easy example of classifications here. I can create the label. Then if I go back to the annotation tab, I add the schema, sorry. I need to refresh. There we go. I just needed to refresh it. I now have this my labels field. And now I can annotate. And say, hey, this is a vegetable. And I've applied the classification. Same idea with bounding boxes. Like before, you can select a class and then draw a bounding box around whatever you need. So again, this is pretty, typical in terms of annotation. But the idea here is we now have this like for the, annotation changes and CRUD operations you need to do, you can do them alongside the other like data set curation and filtering capabilities. Now, one aspect I haven't mentioned yet is on the model evaluation side of things. I want to make mention of that as well. So there is a part of this notebook that I will leave as an exercise to the reader in terms of like the exact running of these, mostly because we're just to the amount of time that it takes on the compute that this notebook is attached to. But FiftyOne supports obviously bring your own models. You can attach any model you want. There's also a collection of zoo models of public world foundation models that world and foundation models that you can use to apply to your data. And this is useful in a couple ways. One, you could just run inference on it. You can run inference using a fine-tuned version of it. You might also use it to perform like a first pass at labeling that you then modify using the annotation tab. So I'm actually going to cut to the chase. We're going to say, pretend I ran these. And again, this is simply using a method called apply underscore model. Once you apply the model, you can then run a FiftyOne brain method that runs core evaluation metrics. So these are the programmatic methods you use. If you open up the app, there are also operators you can run within the app that runs these as well. So for example, here I am in a different data set. Let me load this data set. This is a manufacturing defect detection data set. And if I open up this panel here, I can see there's an operation to apply a model in, for example, a zoo model. Like you can choose the model type and what you want to run against what data. And you can also then run evaluation metrics as well. Like if a model was applied, you can choose your you can choose your prediction field, compare it to the ground truth, assign a key to it, and then actually run the evaluation. And what that then gives you is data in the model evaluation panel that you can use to compare and contrast model performance. Now you can look and at a single model's performance. So once this finishes loading in a second, you'll see the metrics here. Let me make this a little bit bigger. There we go. And let me get rid of a couple of these. And for things like class performance, again, this is just anomaly versus no anomaly. And then confusion matrices, you can actually click on a confusion matrix cell, and it'll only show the relevant samples from that cell. For example, true positive normal samples, or true positive anomalies, or false positive normal, or false positive anomalies. You can also compare models side by side. So I might say, yeah, this was the, was it PATM model? I might look at the equivalent comparison between PATM and patch core. And again, you can see which model is performing better, core metrics. Again, we just have two classes. It's binary, the core confusion matrices, and so forth. Um, there is one last item called scenario evaluation that allows you to go more in depth. Um, I don't think I have that set up here. Sorry, here at the top. Oh, I do. I do a little bit. This allows you to just get more in depth in terms of visualizing model prediction based off true positive, false positives. You can take slices of the data and compare the performance for those individual slices. For example, like one class or one class with this particular attribute, and you can construct what's called scenarios and compute metrics for a particular sample field and filter, right? Okay, so curation, annotation, evaluation, all within the same kind of framework here. So I talked about annotation here, talked about model evaluation. How do we then, like, that's a lot, right? And this is, again, a very you could see how in-depth and kind of composable a lot of these features are, right? The way I think about 51 is if you go to Target and you go down the Lego aisle, you see a couple of options, right? And they kind of fall into two buckets, no pun intended. Option number one is you buy a Lego set that builds the exact thing you need once, right? You're building the Millennium Falcon, you're building the Empire State Building. Option two is you see the 5-gallon bucket at the bottom that has every Lego piece you can think of. You dump it out on your bedroom floor, and then you put everything together, right? 51 is extremely flexible in the sense of it has some of, like, the pre-made. We have the dataset zoo, we have the model zoo, we have the ways in which you can kind of build pre-made workflows like I showed, but at the same time, it's also composable enough where you have pretty much every piece you need to build whatever workflow works for you. However, that can create a learning curve. So for that reason, um, the Voxel 51 team has been increasingly working on ways to smooth out and help you get better onboarded with the experience of using 51. And and one of the initial and kind of core useful ways as a developer is our collection of 51 skills as well as the MCP server. If you're not familiar with what these are fundamentally guided contextual ways of allowing AI assistance to use 51 such that you can prompt them and they intelligently have the information they need around the context of how to use 51, so you don't have to know all the ins and outs of the SDK yourself and just be banging your head against the wall. So Burhan linked the repo here. What I want to do here real quick in the time we have left, again, is hopefully my screen is sharing here and you see my terminal, is I want to open up my coding assistant, which is Claude in my case. And I want to briefly show you that I have these skills imported and turned on. So such that Claude should now have access to these so I can so it knows the kind of 51 best practice ways on how to use things. And I'm going to be extremely like prescriptive here just for the sake of the demo. But if I say something like load the quick start dataset into 51, compute embeddings and similarity, index, sort by similarity, most similar first. Oh, I'll say this just to nudge it. Use skills. That's a little bit of a cheat, right? Because the point of a skill is, the coding agent will call it dynamically. But for the sake of this demo, we'll start it going off to the races. And in a moment, I should see that it's starting to import and use the skills um, that I asked it to. And we can see that off it goes. And I'll let it run for a couple minutes here. We'll see how far it gets. Again, really the exercise is this is doing fundamentally what I showed here by running things in the notebook. But we can see it's starting to call 51 methods, right? And we can see, hey, look, it's starting to find the methods we need. It's loading the data set. It's calling these. Now, again, for those not familiar, skills files are fundamentally markdown files, right? It's textual context. You can guide it further using things like hooks and evals and other ways where you can kind of guide the AI to do things you want. Fundamentally, LLMs are non-deterministic. Um, but we can see that it seems to be, understanding pretty quickly on how to do these things. Um, and it's actually doing kind of a local delegated execution to get this done. And by the way, while that runs, I think that's more of a monitor thing than a 51 thing. Um, looks like it's almost there. Token costs are getting debatable, but skills help with that, right? Because it stops, the better the skill, the less the AI will just spin and spin and spin and spin, trying by through trial and error. All right, now we can see that it's creating a view, right? It's creating a view stage. All right, should be almost there. At least it claims it's almost done thinking. All right, it actually just loaded quick start. So just by the way, off to the side, it loaded the quick start yet. It hasn't applied the view yet, but it's almost there. Sometimes it takes, one thing I did find that LLMs take a second for is when it like opens 51, sometimes it takes a second for it to realize that it's open. It'll apply like a timeout and that sort of stuff. So we'll give it another second here. All right, it claims it's sorting by similarity. It's now creating, I think, a saved view now. I will be on the dangerous side and just let it run arbitrary Python just for the sake of finishing this up. But again, there's not a lot of guidance I need to do here. All right. Let me see. Yeah, there we go. So now if I go to what it ended up deciding to do is here's the quick start data set. So I'm running it locally, and then it created this saved view called sorted by similarity. And to me, this looks reasonable, right? It's showing like, kind of animals and grass first. And then like again, progressively, things get less similar and it looks, but like for me, this looks kind of reasonable, right? And again, in a data set like this, which is very diverse by design, like similarity is like, well, how useful is that? But you get the idea, right? So again, these are ultimately the choices 51 decided to make based off of the skills. So again, my recommendation is if you're new to the platform, but you have an idea of the computer vision workflows you want to do, starting with skills and loading them in and, assuming you can afford the tokens and the hardware, letting it go off to the races a bit is a good way to get started. So that being said, we are just getting at time here. That just about shows everything I wanted to show. Um, Thank you for your attendance. And while we kind of wrap up here, I'm happy to stage this slide and then take any questions from that any folks might have. Any question? I know Burhan was doing an awesome job uh, answering all the questions as they came up, but I'll stay on for just a couple minutes. Um, as we wrap up, just note again, we do have a very active 51 community that you'll find Burhan in almost every day in Discord. We highly encourage you to join that. That you can get all the latest on what's new with 51, the events that we do, especially as CVPR is coming up. We're going to have a lot of stuff there to talk about and to show. If you're at CVPR, we certainly hope to see you there in Denver. But again, especially if you're new to the platform, if you're considering next steps, do please, engage with us in Discord. We are more than happy to help. And again, expect a follow-up email as well. That includes the workshop notebook, the slides, and then additional upcoming events and resources as well, the workshop recording as well. All right. Well, again, thank you, everyone. I'll stay on for just another minute or so, and then I'll close things out.